Alright, let's look at this. 5-3. I started it on Thursday with a couple of seniors, so y'all, the first couple of slides, actually the majority of the slides, y'all already have done, but we had, I don't know why, we had too many out on Friday, and it really threw the damper in things. So let's look at this. Here's what I need you to understand. If you remember me saying 5-5 is on the final, right? It's on the final exam. I think there were 2 of them, if I remember correctly, 2 questions from 5-5. We already said 5-1 is on the final as well. I'm going to put FE, it's on the final exam. So I know y'all thought, well, let's just cover 5-1 and 5-5. Well, 5-2, we're already done. 5-3, we're about to do. And 5-4, we're about to do. Here's why we've got to cover these 2. First of all, I am going to trim the fat in them, so we're going to get through them faster, and we're going to cut out the stuff that's not necessary for 5-5. But you have to see 5-3 to learn how to switch between log and exponential. You have to know how to switch. Then you have to see 5-4 to learn how, like the addition, subtraction, I'm going to say rules of logs. You have to learn those in order to get to 5-5, which is just solving log equations, which entails being able to switch and knowing the rules. So that's why we absolutely have to go through 5-3 and 5-4. We have to hit them to cover those aspects because that is directly linked to 5-5. 5-5 is nothing new. 5-5 is just now put those together and solve the equation. Okay, so there's your roadmap for where we are. 5-3, we are going to cut out the, is there a word problem? There's one word problem. We're going to cut out the word problems in 5-3, and then I will cut those out of the homework as well. Also, the graphing, we will just discuss what type of transformation it has, because you just need to be familiar with that. But we're not going to worry about actually graphing it, because it's not tied to 5-5, if that makes sense. So our goal is being able to do 5-5. So what from 5-3 do you have to know to be able to do 5-5? Is everybody with me? All right, yeah. Oh, it went good. It was fun. He was trying to confirm what the kid was saying. That was all. And the kid was wrong. All right, look at this. So what's in front of you right now is explaining the relationship between logs and exponential equations. What's the inverse of addition? Subtraction. What's the inverse of multiplication? Division. What's the inverse of squaring? Square rooting. Okay, so what's the inverse of exponential? Log. And then here's the visual behind it, and this is the case with all inverses. If you graph a function and its inverse, they will have this really nice symmetry over the line y equals x. And that's because, if you go back to 5-1, how do you actually find the equation of an inverse? Remember, you switch x and y and solve for y. With inverses of exponentials and logs, there's a different relationship. Now, you might look at this graph and wonder what's going on here. This one was exponential growth, and then this one is exponential decay. So it's just showing you, should it have been a decay function, here's what the inverse would look like when it reflects over that nice line of symmetry. So that's the point of this picture right here, this slide. Go into this slide. Okay, find each of the following logarithms. So look at your calculator. Do you see a log button? It should be on the left side, I think. 5 to 7? Never mind, it's not on the left. Oh, it is on the left. Okay. Get my bearings. Alright, it says find each of the following logarithms. There's two ways to do this. One way is to type it in your calculator. Another way is to understand what a logarithm means in terms of exponentials. So we're going to go ahead and just do both so that you can start seeing how to change from log to exponential, which ties right into 5. So at the top of your paper, I want you to write, you're going to write two formulas with a big arrow, double-sided arrow in between. When you have a log, let's say log base A of X equals Y. Notice the base is subscript. The way you would read that is log base A of X equals Y. That's how you would read it. If you want to understand how a log is related to an exponential, here's the conversion. Drawing a double-sided arrow because it can go either direction. What is the base of the log here? A. The base of the exponent is the base of the log. So when I say the base of the exponent, I mean like the big portion and that the exponent's attached to, right? That's called the base. So the base of the log is A. The base of the exponent will be A. The other two values, notice where they are on the equal sign, they will switch sides of the equal sign, which means when the Y comes over here to the left side in my exponential part, it's not going to go right next to this, it's going to be the exponent. So the base of the log is the base of the exponent, and the other two switch. And you just have to know that the one that's coming over right next to the base is going to be the exponent's place. Does that make sense? Now, the way, let's write right here, base of log is base of exponent. Base of the log is the base of the exponent, the others switch. Okay, so we're going to practice evaluating these by going ahead and writing them as exponentials so that you can start wrapping your mind around the relationship. Technically, I could sit here and solve all of these with my graphing calculator in like just a minute. I'm going to show you how to do that as well. But I want you to go ahead and start practicing the switching so that 5 is easier. So if you look right here, this is just an expression. It doesn't say like equals something, right? So we're just going to say that it equals question mark. We're going to make it an equation so you can start seeing these conversions. All right, so here we go. The base of the log is what here? 10. The other two switch, which means that the part that's coming over here next to the 10 is going to go to the exponent's place. And then now you ask yourself, 10 to the what power is 10,000? Well, 10 squared is 100. 10 cubed is 1,000. So 10 to the 4th would be 10,000, right? So this is 4. Or you can put the 4 here, whatever. I'll write it right there. Oh, jeez. I'll write it here. Now, let me show you how to type it in the calculator. Your log button on the calculator, do you notice there's no base written? That's because the natural base, like the understood base of any log is 10. The natural value for any log is base 10, the standard base. So when you push the log button right there, there's an understood base 10 that you can't see. Since that's base 10, that means I can type it right here using the log button. So I'm just going to type the of part, of 10,000, and then hit enter. So the next one, log of 0.01 is -2. And you might be wondering, like, how is that -2? Let's go back and look at our little conversions. So if this is equal to something, and I'm going to switch it to exponential. The base of the log is 10, the other two switch. So now wrap your mind around it. If 10 to the 4th is a giant number, then 10 to some negative number is going to become a small decimal, right? And that's why this is -2. Because it's saying move the decimal place two spaces. Now, can you type C in the calculator with the log button? Why not? Because it's base 5. So let's make a note down here that calc log button is base 10. The log button is base 10. Now, it's a standard graphing calculator, right? So you might think, well, there's got to be some other way to enter another log that's not base 10. There is. I'll show it to you. Let's try this first in our head. So we have a log equals to something. Let's convert it. The base is 5. The other two switch. So 5 to what power is 125? 5 to the third power. So the answer is 3. Now let me show you how to type it in the calculator. Remember, the log button is only when it's base 10. Here's how you type a log that's not base 10 in the calculator. It is the math button. The very first column is just math functions in general. There's two ways to get to it. You could sit here and scroll down every single one of these, or I prefer to go the other way, which is where you scroll up, and it'll bring up the bottom of that menu. Do you notice A says log base? So go to that one, and now it's going to actually allow you to enter a different value for the base, and you type exactly what it looks like. So in this case, 5 of 125, and it'll evaluate it. Okay. So enter this one. Log base 9 of 3. So math, arrow up. We've got base 9 of 3. It says 0.5, which is what fraction? 1/2. Now, I want you to take some notes here to understand why 1/2 was the answer. So this came to 1/2, right? Let's rewrite it. I'm going to circle this since that was the answer. All right, the base of the log is what? What's the base of the log here? 9. The other two switch, and the one coming over here is going to go to the exponent's place. Right? Now go back to your rules of exponents. When you have a base to a fraction in the exponent's place, it translates to a square root, cube root, fourth root, fifth root. It all depends on the denominator. So that is a square root of 9 to the first power, which now you can see this is why it says equals 3. That's why the answer was 1/2. So now let's come down here and let's adjust our notes. Log button is base 10. are for not base 10 or other than base 10. Here we go. You're going to hit math. You're going to arrow up. And then you're going to select the one that says log base. And then you can enter it as you need to. The last two, don't enter those in your calculator. Let's see if we can do those in our head. Think about it. Think about your rules of exponents. Okay, so this is equal to question mark. So here we go. The base is 6. The other two switch. 6 to what power is 1? Yeah. Remember the rule of 0 in the exponents. If anything to the 0 power is 1. Alright, look at the next one. Equals what? Let's convert it. The base is 5. The other two switch. 5 to what power is 5? 5 to the 1 power is 5. Go to the next slide. Now you will practice just converting. This is where it's technically teaching you how to convert it. I already taught it to you. This is their way of writing it. I will say right here, I personally, I don't like to put the exponential part on the right. It messes with my head. I don't know if it's going to do the same to you. But I always list the base first, and then I switch the other two. But it doesn't matter how you do it as long as you have the correct base, the correct exponent. This up here, these are the two special cases that we just covered. We just had 2 practice problems of them. Like log base A of 1. Anything that's log, whatever base, of 1 is the answer 0. And when the base and the of match, the answer is 1. You don't have to memorize that. You could just rewrite it as the exponential and then you would see it. Okay? I'm not saying memorize that. Alright, come right here to these two. Make sure to understand the directions. Notice it just says convert, right? That means don't evaluate. So you're not typing this in the calculator and writing the answer. You are simply converting it to the other form. Know how to recognize when it's in exponential and when it's in log. When it's in log, you will see the word log. When it's in exponential, you're going to see a power, an exponent, okay? A is exactly what I was just saying right here. I don't like when the exponent part and the log part on the right-hand side of the equation, it messes with me. So I'm going to take this and I'm going to just switch both of them because that's just part of my rhythm. You don't have to do that. It still works the same. We're going to log form. What's the base of the exponent here? Find the exponent and then tell me its base. The base is 2. So this is going to become a log base 2. And the other two do what? Switch. Which is exactly why I prefer to write it that way. Where the exponent's on the left, the log's on the left. Because that whole switching thing works every time. Okay, you do the next two. Don't let the E throw you off. Treat it as a regular base. Are y'all done trying those two? Alright, check your answers. So the base here is 10, and then the of equals -3. You technically, when it is log base 10, you don't have to write 10. You can write it like this. And they're both correct. It's up to you. I personally still write the 10. Sometimes just to remind myself that there is a 10 there. Because, you know, you're used to when there's an understood number, it's a 1. Now it's a 10. So, alright, this one right here, e to the t equals 70. The base of the exponent's e, so this is log base e. The other two switch, and I'm done. It's not asking me to evaluate, it just wants me to switch it. Now let's go the other direction. We're given logs, they want exponentials. So the base of the exponent will be what here? 2. The other two switch. So what's the power? Equals 32. You've got to be able to do this to be able to do 5, 5. Okay, this directly ties into 5, 5. So make sure you understand this. What would the base of the exponent be here? A, what's the power? And then equals Q. C is another one of those that bothers me, throws off my rhythm, because the log's on the right side. So on my paper, I just say, oh, that equals X. That's how I switch it on my paper. Now the log's on the left side, and now I feel like I'm in my OCD comfort zone. The base of the log is T, the other two switch, and that's the answer. Any questions? Okay, go to the next slide. What if it's ugly? What if we just are trying to understand what is the log, type in your calculator? First of all, you need to make sure your calculator is in real mode. And there is a good chance yours might be in imaginary mode. So click mode on your calculator. Look and see if it says A plus BI highlighted. If it does, you need to change it to real. And then you are just typing these three in. Notice there is no base here, so it's understood to be 10, which means we can use what? The log button, right? We can use the log button. I just had to check that. My recording looks like it disappeared. Alright, so we're going to type A in. Log button 645778. Hit enter. Oh, am I in real mode? Yeah, I am. Now it says go to 4 decimal places, which means check the fit. Some of y'all were struggling with rounding. I've had to go in and give a lot of partial credit with rounding errors. Please try to fine-tune your rounding skills. If it says go to 4, that means check the fifth. You don't look at anything else after that. So the fifth number here is 8, which would bump the fourth number up to 1. So this is 5.8101. Type the next one in. Just gotta watch your zeros here. There's 4 of them. Alright, take second, round it. Alright, tell me what you got when you rounded. type the last one in. Log of -3. What happens? You get an error. Now, instead of just saying error and moving on, let's understand it. Let's put right here equals what? Remember, this was base 10. So the base of the log is the base of the exponent. 10 to what power is -3? Well, wrap your mind around it. 10 to the first power is 10. 10 to the second power is 100. 10 to the third power is 1,000. Is there any way to take a 10 and multiply it by another 10, however many times, and get 3? Much less -3? Like, it's not possible. So because this is saying take 10, raise it to a power, and get a number that's not possible, it's not real. This goes into imaginary solutions. So the way we would answer this is we would just say not real. Which doesn't mean like it's fake. It means imaginary. Let's make a note down here. Just a reminder. If the base is missing, meaning not labeled, then it's understood base 10, which was the case on all of these. If the base is missing, it's an understood base 10 every time. Which takes us to the next slide where we are introducing what's called natural logarithms. Natural logarithms. What's the abbreviation? It's LN. So it's a little backwards. I guess NL didn't have as much of a nice ring to it. But LN stands for natural log. Okay? When you see me write LN, you're going to see a cursive L so that it doesn't look like like if I was saying, in his play, I'm just making up a sentence. You see how my capital I looks like an L, lowercase l? So, my LN is always a cursive L, so that you don't mistake it for an I. What's the takeaway here? 2 takeaways. First of all, there is a nice fancy little LN button. See it? Don't you love that? I love when there's a button. There's an LN button. What do you notice is right above it? E. You remember E from the other lesson, 5.2? E and LN are inverses of each other. Okay? So here's another big takeaway. If you were here on Thursday, I don't think we wrote this. You need to know that LN and E are inverses. Log and exponential, I'm running out of room, are inverses. Okay? LN and E are inverses. Log and exponentials are inverses. Now, sometimes log and E will be in the same portion, and that's right here. Look at this. Ln of x, right? If I said ln of x, I can change ln to log base e because they're one and the same. They mean the same thing. It's not that they're inverses. It means they're equivalent. Right here, ln of x means log base e of x. And it's really important that you know this because 5's coming down the pipes, right? You need to know that ln of x can be rewritten as log base e of x, or vice versa. If I gave you an equation with log base e, and you don't want to deal with the e, you can rewrite it as ln. And then there's an ln button. Okay? So this slide is really, really important right here. This slide is. Also, is it on there? Oh, I turned my page already. Yeah. So this slide's very important because of that right there. And then it brings us to this. These are, once again, special cases. One of them comes up a lot, and it makes your life so much easier if you can memorize it. It's this one right here. I'm going to box both of them in, but then I'm going to draw an arrow to the one that makes life easier if you can memorize it. If you can memorize that ln of e equals 1, when we do 5, 5, it will make it easier. Now I'm going to show you why ln of e equals 1. Actually, let me back up. What's 3 divided by 3? 1. What's 5 divided by 3? I'm sorry, 5 divided by 5. 1. 10 divided by 10. Pi divided by pi. Okay. ln of e. It's 1. Here's why. What did I say ln of e, or ln can be written as? The ln. This little block right there. What did we say that can be written as? Log of e, right? Log base e. And then it's of e. Look at that. Remember when the base and the of match? The answer is 1. And that's exactly why ln of e is equal to 1. Because if you change the ln to log base e, and then the rest of it's still there, that's why it's 1. Okay? Memorize that. Understand it's because of this. So that if you ever forget to memorize that, you can at least rewrite the ln as log base e, and then hopefully you remember that when the of and the base, like when the base and the of match, is 1. Okay? Find each of the following natural logarithms on your calculator, which means type it in, round to 4 decimal places, and go. You're using what button this time? ln button. You're going to 4 decimal places. Do all 5 of them right now. 5, 5, you have to know how to switch, because you can't do that in the calculator. And then once you can get it to the correct, to the other form, then you can use your calculator. Yeah. So these 5 questions are just typing it in. So the first one, you get that decimal, and then you had to round to 4, which means check. 5th one, Did you get 13.3782? Okay, here did you get negative 10.6416? Here did you get an error? Which means not real. Let's understand why. ln of negative 5. Okay, so I cannot understand why it's not real by looking at the ln. I'm going to change ln to log base e of negative 5. So that's saying e to some power is negative 5, and e is 2.7, yada, 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 yada. So there's no way to manipulate e, especially because e, it keeps going. It's like pi. There's no pattern, it just keeps going. There's no way to raise e to a power and get just negative 5. Not possible. So that's why it's not real. Did you have to type that one in? Or do you remember? It kind of has a flow. Just remember, ln of e is 1. Just remember it. It's 1 every time. And it's because it's log base e of e, when they match, is 1. Ln of 1 is 0. Now, the next slide is called the change of base formula, which is very helpful when it comes to being able to evaluate logs that are not base 10 if you have a calculator that does not have the nice little log base feature. So look at this slide. This slide was for when calculators didn't allow you to enter non-base 10 logs, okay? Now they do. So this is almost kind of an antiquated formula, but it's still helpful when solving logs and you have to rewrite them. Let me explain the change of base formula, and then I'm going to show you a corny little way to remember it. It's saying, let's say you have some log, base b, not 10, just base b, of m. Okay, instead of this single log, you can rewrite it as a fraction where a, log base a of m and log base a of b are the natural logs, which is base 10. Okay? You might not understand that, so let's apply it here, and then I think you'll understand it. So we have log base 5 of 8. I don't want to evaluate this in my calculator with the log feature. I want to be able to evaluate it with the regular log button, which means I need it to be in base what? 10 mode, right? So I'm going to apply what's called the change of base formula, and I'm going to write it as 2 logs with base 10, and then I can type it in my calculator. Here's how you rewrite it. First of all, it's going to be a fraction. You might think, oh Lord, why would I want to write a fraction? Just watch. The change of base formula says, notice right here, the original base becomes the log of where in the fraction? In the denominator. So the way that the stupid, corny way that I remember this without having to look up the formula is I say to myself, okay, I cannot evaluate that with the log button. So I'm going to rewrite it, and I always say the bottom, the small, the subscript, the base, goes to the bottom of the fraction, and the other one goes to the top. So this would be log of 5, and the other one's on top, log of 8. Notice the 5's written really big now. Because what did we just make the base? 10 on both. There's an understood tiny 10 here and here that you don't have to write. Now I can type it in my calculator. I type it exactly how I see it. Alpha y equals fraction log of 8. Oh Lord, hit the tangent button. Log of 8 over log of 5. Enter. Now, just to show you that we did it right, I'm going to go to that fancy log button. So, map up. And now I'm going to type the original. It was log base 5 of 8. And you'll notice it's the exact same decimal. The point of this slide was being able to evaluate the logs without using that feature on your calculator. Because not a lot of calculators have that feature. So they had to come up with some way for you to rewrite it. Now let's make a note up here. The base goes on bottom. So the original base will be the bottom part of your fraction, and then the other number goes in the top. So right here, log base 5 of 8. Actually, let's skip around. This is why I should switch this. Well, y'all's is not switched, is it? No. Is it going to mess y'all up if I just switch them up here on my board? Y'all good? There's a reason I have the extra example there. And that's because, do you notice how this log is the exact same? But notice it says use the natural. I don't want to do the natural yet. Alright. Find logarithm using the change of base formula, which means you're converting it to that fraction with base 10. So here we go. You try it. Write the fraction, then go to your calculator and evaluate it. Then use the fancy log button to check your answer. Alright, I think you got it. Log base 8 of 14. I can't type that in using my regular log button because it's base 8. That's the base. That's in the subscript, so that goes in the bottom, and it's just of regular 8. And then the top would be 14. So that's log 14 divided by log 8. Did you get 1.2691? Oh, I forgot to write the decimal right here. We typed it in the calculator. So this was 1.2920. Okay, now let's do the one that says natural logs. When it says that, it means they don't want you to use the regular word log, they want you to use ln. Okay? If they want you to use ln, right, natural logs, that means ln. That means we need to have what in here? Log base e. That means we've got to use log base e. So they want us to take this regular log, rewrite it as log base e, and then clean it up into ln. All right, so we've got log 5 of 8. I'll come over here. Log base 5 of 8. They want us to apply base e using the change of base formula. So which one goes on bottom? The 5. 5. So it's going to be log base E of 5. What goes on top? Log base E of 8. And then now they want you to change. Remember, this is like those little wooden blocks that kids play with. If log base E is painted on the front, what little other wooden block could we push in its place that's smaller? The natural log, which is ln. So I'm going to write right here, this would be ln of 8 over ln of 5. They are one and the same. And then now you can type in your calculator ln of 8 divided by ln of 5. And you should notice you get the exact same decimal as right here when we did log base 10. Did you notice that? Little outdated because now calculators have the nicer log feature. However, it is important to understand the relationship, and I have used the change of base approach when solving logs. When I didn't want to just jump straight to my calculator, I wanted to do because I call it algebra. I wanted to do the algebra behind it. I like manipulating, rewriting, trying to see if I could solve it without just going straight to my calculator. The change of base formula, if you see that phrase, this is what it means to do. Or if you see common logarithms, that phrase means they want them to have the same base. They want you to have multiple logs, plural, with the same base from the one log they gave you. Okay, so make sure you understand the language here. Change of base formula is obvious. Common logarithms, not quite so obvious, but it means take the singular, make it into plural, and they better have the same base. Okay? Which is base 10 unless they tell you otherwise. Right here. Next slide. Sketch that graph. This is what log base 5 of x looks like. Just to kind of wrap your mind around it, like to get an understanding of spatial awareness. This is not on the final. This is not on the chapter mini exam either. It's just kind of sketching. It doesn't have to be perfect. But I wanted you to see this, like have a spatial awareness of where a log function is on the graph. All right, sketch this next one. This is the ln of x graph. The next two slides, the next slide has two little questions. It says graph these by hand, but describe how it's transforming. So I want to refresh you. Once again, we got those transformations that come in. So look at A. A says ln of x plus 3. What's the mother function here? Ln of x is the mother function. Okay, remember your transformations. Anything that's in brackets, bars, parentheses, whatever, is a horizontal type of transformation. It just says plus 3, which is counterintuitive. That should make you think right 3, it's actually left 3. So we're just going to make a note. This would shift left 3. So I'm just going to come right here and draw a sketch from -3. Now the next one's a little trickier because the mother function is at the very end of it, which is very backwards to our normal approach, right? So I'm gonna do the cup game. Remember, where you just take the terms, keep their signs, and you just rearrange them. So negative 1/2 ln of x. I'm gonna pull that to the front. Got the negative. Negative 1/2 ln of x. And then that's a positive 3. I'm going to put that at the end. And then now I can understand it a little better. So there's 3 things happening here. The negative in the front means it's doing what? Reflecting over the, it's in the very, very front, so it's reflecting over the x-axis. If it was next to the x, it'd be reflecting over the y. Remember, anything by the x is counterintuitive. Alright, so it's reflecting over the x. A stretch or a shrink in the very, very front is the whole rubber band thing. Remember this? Not a good rubber band to do. But do y'all remember this? Where I was like, lots of energy, stretches it, very little energy, makes it really wide because the floor and the ceiling are caving in and it doesn't have as much room to curve. So this would be a vertical shrink, and then it's shifting. Now that's at the very end. That was inside parentheses. That's at the end, so that's up 3. Remember, at the very, very end is up or down. Inside, parentheses, brackets, bars, anything. Think of big old, like a big old capital H. Think of horizontal. Okay, so inside something is a horizontal. Right on the very, very, very end is up or down. And in this case, it's up 3. So you got reflect over x-axis. I'm going to put V shrink by 1/2 and shift up 3. So if it reflected down, well, oh my gosh, I did too much. Stand by. There we go. So just kind of sketch up in quadrant 1. The last slide we will omit because it's a word problem, and we're not doing the word problems right now because they're not on the final exam from this section. There are word problems on the final exam, but they're from sections you've already done. So you can write omit on 12. Are there any questions? Okay, you need to finish your 5-3 homework tonight.